Hello, my name is Ivan Fetch, and I'm a site reliability engineer with Fairwinds. I'd like to talk a bit about passing configuration and other information into your applications running in Kubernetes. It's helpful to separate application configuration from your application container images. This makes images more portable and allows you to apply the same image across multiple environments while still varying the configuration per environment, such as staging versus production. It's also easy to change application configuration without having to rebuild your container images. Sensitive configuration, such as passwords, is protected in Kubernetes using RBAC or role-based access control. This allows you to define who can access these sensitive secrets. Kubernetes provides both ConfigMaps and secrets to store configuration information, and you can make that available in Kubernetes pods using either environment variables or files. This demonstration will make information from Kubernetes and also pretend application configuration available to Kubernetes pods. Please note that the Kubernetes manifests used for this demo are also available in a GitHub repository. See the video description for that link. This Kubernetes pod manifest already showing on my screen outputs multiple environment variables and loops to avoid the pod crashing. We can look at this output later in Kubernetes pod logs. Looking at the vars-example container definition, I'm using $ with parentheses to incorporate the value of environment variables into the command or arguments run inside the container. I'm also setting resource requests and limits. The resource limits will be referenced later in variable assignments. In the env section, I define a number of variables, the first of which is called purpose and is set to the static string to be the best Kubernetes pod. I next create variables CPU limit and memory limit, which are assigned from the values specified above in the pod manifest. For the CPU limit and memory limit variables, the container name is optional and allows you to specify a different container in the same Kubernetes pod. The resource field is set to one of request.cpu, requests.memory, limits.cpu, or limits.memory. The latter two I've used here. The divisor field is an output format or multiplier that's applied to the number assigned to these variables. This defaults to 1, core for CPUs, or byte for memory. Here I've used the divisor that matches the limits definition for readability. Next, I create variables for pod name, namespace, and node name. These get information from fields in Kubernetes. The field path can be set to, for example, metadata.name for the pod name or spec.node name for the name of the node where the pod is running. Let's take a look at the output from this pod. I'll run kubectl logs example1, and I see that the output says this pod's purpose is to be the best Kubernetes pod. It's named example1, running in namespace default, on node, whatever. It has a CPU limit of 250 and a memory limit of 25. I've outputted this information here for demo purposes, but your app could actually act on this information. Next, let's take a look at using ConfigMaps and secrets to put configuration information into a pod. I'm going to apply and take a look at this example2.yaml pod manifest, and we'll walk through a couple things. Under spec and volumes, I create 2 volumes for the pod that the containers can mount. One of them is a secret, and the other is an optional config map. By optional, I mean that the pod will still run if this config map doesn't exist. Under volume mounts, I define mounts for the volumes above. Config map is mounted under /app/config in the container, and the secret is mounted under /app/sensitive. There's environment variables, this time defined under env from, instead of, like the previous example, defined under env. These variables are first set from a config map and second from a secret. The secret is optional. In this case, the pod will run if the secret doesn't exist. Any variables set in the secret will override the same variable if defined in the config map because the secret comes second. It's also possible to target a specific key when using a config map or secret to create environment variables instead of using the entire config map or secret to define all their variables. Let's describe this pod by running kubectl describe pod example2 and see if the pod's running. I see the mount has failed for the sensitive config volume, and this blocks the pod from starting. The example2-config secret doesn't yet exist, but even if it did, the example2-env config map doesn't exist, which would have kept the container from being able to run. Let's go ahead and apply and then look at these missing resources. This example2-config secret under the data key defines api.json, which is set to a base64 encoded string that, when decoded, will be a JSON file. This file will be mounted under /app/sensitive. The example2-env config map sets the message variable to the string hello world. Now that the required resources exist, let's run some kubectl exec commands to look at the message environment variable and some of the files in this pod. Running kubectl exec commands to look at the message environment variable ls and cat a file from our container, I see that message is set to the string hello world. This comes from the example2-env config map. I see that the directory /app/config is empty because the optional example2-config config map hasn't yet been created. However, the file /app/sensitive/api.json exists. It's been base64 decoded and shows our JSON that our application could read. This comes from the example2-config secret. Let's now create the optional secret and config map that this pod is also configured to use. The optional example2-env secret also sets environment variables. This is setting the message variable to thank you for watching. This will override the variable set earlier in the config map. There's also a couple additional variables added for database username and password. Next, we'll take a look at the example2-config config map. This creates files, and the app.conf file has two example config lines that your application could read. This is mounted in the directory /app/config. Let's go ahead and redeploy this pod so it uses these two new resources that we just created. If I run similar kubectl exec commands again to look at the message environment variable and some of the files inside of the pod, I see that message is now set to thank you for watching. So this has been overridden by the new secret from the earlier config map. The file /app/config/app.conf also exists. That comes from the recent example2-config config map. You might be wondering how to turn your application config files into a Kubernetes manifest for a config map or secret. You can run the command kubectl create config map or kubectl create secret, including the -o YAML option, which will output the manifest instead of creating a resource in your cluster. You can use --from options to use a file or directory of files as the source for your new config map or your secret. Thank you for watching. Remember to check the link out in the video description if you'd like to see the GitHub repository that contains the manifests used in this demo.